volume. All right, we are now moving from two-dimensional area, which are flat things, to three-dimensional area. Okay, we're going to be focusing on volume. We'll spend 4 different lessons on this, dividing 7.3 up into a couple different things, a couple different days. Okay, so we're going to focus on circles, squares, and other shapes that we cut. Okay, Riemann is just means it's what turned into an integral. A Riemann it was a limit and it had a sigma. We were adding up rectangles. Riemann and rectangles. That's it, right? When we were doing area, we did Riemann, but we started with the shape of a rectangle.
Yep.
That was like the first lesson was LRAM of this semester. LRAM, RRAM.
LRAM,
Yeah.
RRAM.
So now we're going to move into circles, squares, other shapes.
Yeah, that whole thing.
All right. So what I was just demonstrating for you is called the method of slicing or the method of cross sections. So think about different loaves of bread. Maybe if that loaf of bread, everything is pretty similar. All the pieces that you slice are fairly much the same size. But if you're slicing like a sourdough loaf or a French loaf or something where the sides are not all straight, then the different slices of bread are going to be different slices. Okay, there's a potato. Sometimes I bring a potato in and I slice that up. Okay. Watermelons, not a good season for watermelon right now, but you could slice watermelon, then you get triangular sections or close to triangles. We're going to have triangles. We'll have circles, we'll have squares, we'll have rectangles, we will have some triangles. We even have some diamond type shapes.
What kind of knife is that?
Okay, that's a vegetable peeling knife. All right.
Oh, what?
Here's some. When school used to go into June, remember when you were quite a bit younger, and we had school past Memorial Day into June, we would build these three-dimensional models in class. It was after the AP exam. We had nothing, it was nice. We watched a movie, but we don't have time to do that anymore because we end school early. But these are some pictures of projects that my students made to show. So see the one that says e to the x? Yeah. The e to the x part is the curve that's going up like that. Mm-hmm. Okay, so it was showing each one's getting taller according to e to the x function. And they were getting, it was a shape, those shapes were rectangles that were getting bigger and bigger and bigger and bigger. The other one was a cone. And that was just formed by the diameter shrinking as you went. They were half circles, but that diameter would get smaller and smaller and smaller and smaller all the way down to a tiny little point. Here's some that are just done by computer generated. Okay, so you can see, if you were to estimate, what would you think that this one here, as it got bigger and then started to get back smaller again, what curve do you think that's following?
Parabola.
It could be a parabola. What other curve does that? Could be sine, for sure. Cosine.
Technically.
It could be a different part of cosine, but.
Technically.
Okay. All right.
Oh.
Okay, so first we need to understand how to find distance. Okay, how to find the distance between any two things. Yeah. All right, so distance, if you're on a line. Oh, you don't have that one?
Nope.
Okay, never mind, we'll skip it then.
Awesome, we have the method of slicing.
This one?
Yeah.
Great.
It's like, awesome, let's skip it.
Well, I'll tell you. If you're finding distance on a line, okay, so if I tell you, Noah, you're on a line and you're at number 3 on a line, and Tyler, you're on the same line, but you're at number 11. What's the distance between you and Noah?
7.
Oh, no.
8.
8. Okay. How'd you come up with that? Okay. You added them?
No.
Subtract it. All right, but which one did you subtract? Did you do 3 minus 11? No. You take the bigger one, right? So if you're on a line, it's x2 minus x1. Okay, the larger one minus the smaller one. Okay, if you're doing distance in a plane.
Distance in a plane.
Okay, so it's an XY plane,
Oh,
not an aeroplane.
bad.
Okay, but distance on a plane. So now you have 2 dimensions. It's
I
not
don't even
just x2 minus x1, but we're now in 2 dimensions. So the distance is, yes, it's x2 minus x1, but you have to square that because you're in 2, and it's y2 minus y1, and you gotta square that. And then you gotta square root the whole thing. Where does that come from? That's a Pythagorean theorem. That's a squared plus b squared equals c squared. That's how you find the distance on a plane. 2 dimensions. All right, how are we gonna do distance in 3 dimensions?
Z?
We're not gonna introduce a new variable.
Oh, okay. So cubit?
We're gonna use calculus.
Oh.
We're gonna use an integral, okay? And we don't wanna bring in a new variable. That means something totally different. That'll be Calc 3, that's called multivariable calculus, where you bring in z variables and everything. We are just gonna do it by using an integral, yeah.
That's a few steps too far for me.
All right.
Okay.
Okay.
The bound.
Is this Calc, what is this, Calc 1?
Calc 1.
This is Calc 1 and half of Calc 2.
Okay.
So if you go to college and you sign up for Calc 2, you'll start with RAM, LRAM, RRAM, TRAP. You'll
start over?
You'll go through what we are doing right now, and then you'll go beyond, right? So in other words, it's the same as BC. Like you go as far as the BC people are doing. All right, here is your steps. And I promise you that these 2 are going to be the hardest parts because they're the ones that involve shapes and geometry.
Oh,
Carla's favorite.
Yep.
Okay, so this is going to involve shapes and geometry. You got to know some basic things. You got to know how to do circles, pi r squared. You got to know how to do triangles, 1/2 base times height. You got to know how to do squares. You got to know how to do rectangles. Okay, that's the hardest part is step 1 and 2, figuring out what shape you're dealing with and coming up with the equation for the shape. Once you have your geometry shape done, the calculus part is easy because you just throw an integral on it, and then then it turns it into volume. So an integral. So here we have in the pink bar the volume of a solid of an integrable cross section. That just means it's continuous. There's no gaps in it. That's what integral means. Okay, from A to B. To do volume, you integrate the area from A to B. It's that simple. It's the area part that's the hard part. Okay, you find your bounds, but it's your area shape that's going to be the toughest, and that's why we're going to practice that. Okay. All right, here we go.
It's a croissant.
It's a croissant.
A croissant, very nice. I like it. Okay, it's a croissant. Okay, we can see that the shape of this, the geometry, is semicircles. So we have to start with that. All right, so our area is semicircles. The semicircle would be 1/2 pi r squared. We need a 1/2 pi r squared that's going to match the picture that we are given. I like to focus on the biggest slice I can see and kind of start from that. So let's start here. Let's focus on this one. Okay. All right, so here's a semicircle. All right. Or any semicircle. Okay. The diameter of these semicircles stretches from where to where? Where's the diameter on each of them?
Zero.
Stretching from
The x-axis.
the x-axis to the function. Okay? All right, that is called the distance. And we just did how to do distance. So we have the x-axis down here to the function, which is 2 sine x. So the distance of the diameter And we just did x2 minus x1, or whatever, the bigger one minus the smaller one. So what would you say is the distance of the diameter? What two things does it touch? Is the x-axis bigger or is the function bigger?
The function.
Okay, so which one goes first?
2 sine x.
2 sine x minus 0. That is the diameter. It's the bigger one minus the smaller one. So since the diameter touches both of them, we subtract. So that's called the equation of the diameter. If you know the equation of the diameter, how do you get the radius?
Half it.
Times half.
Okay, multiply by half. So then the radius would be half of that equation, which gets me what? Sine x. So now I can go back to my geometry, and I know that the radius is sine x, so this will be 1/2 pi times sine x quantity squared. That for every problem is the toughest part. It's coming up with an equation for the geometric shape using the variable x off of the picture that we're given. Turning it into volume should be easy.
Should be.
Should be. Turning it into volume will be the integral going from where to where according to the picture, 0 to pi, of this geometry thing we just came up with. And then Math 9 does the rest for you. Okay?
Oh, distance of diameter. How do you know which equation to use?
For the diameter?
Yes.
Well, I have two equations.
Okay.
In the picture, y equals 2 sine x was labeled,
Yeah.
but the x-axis is also an equation. The equation is y equals 0. That's what so there are actually two equations, and I'm using both. But you use subtraction because the diameter touches both the y equals 0 and it touches 2 sine x. Because it uses both, you subtract them to find the distance, just like you and Noah subtracted to find your distance.
I know which one's bigger.
Well, 0 is pretty small.
Oh, that would you mean.
Yeah,
Okay, that makes more
but
sense.
yes, and 2 sine x is going to be bigger.
Okay, that makes more sense.
Yep, yep.
Wait, was this one the homework?
There's 2. I think.
There were 2 used on the homework.
Yeah, 2
Yeah,
volume.
this is like questions on volume,
Oh,
like
last night?
Yeah.
Yeah.
Ooh, on distance
Yeah.
Yeah.
or on volume?
Volume.
Volume.
Ooh. Okay.
Yep, I definitely tried it.
All right.
Wrong.
I
but-
should remember why I had that.
Is there anything constant I could pull out of this integral?
1/2 pi.
1/2.
1/2 is constant and pi is constant. So I would recommend doing that, pulling out 1/2 pi to the outside and leaving this 0 to pi and then sine of x quantity squared dx, and then let your Math 9 do the rest of it. We're not going to spend our time typing in Math 9. We're just going to practice the geometry and the volume. All right, let's try a different shape. Oh, we get to draw this one this time.
How much of these are we going to be drawing?
Half, maybe. All right, how do we draw this? Well, they tell you what shape it should be. It should be parabolic, but it's x equals y squared. Do you guys know what direction the parabola goes if we draw that?
To the right.
Okay, so it's opening like that. So if I were drawing it normal, it would look like this. I'd have both the top and the bottom.
But you can't do
Okay, the top, if I got it in y equals equation, what would it be? Y equals what?
right.
Rad x. And the bottom would be y equals
Negative right.
negative rad x. Okay, that would be a normal drawing. If we're trying to make this three-dimensional,
The plus and minus makes sense now.
okay, you're trying to make it three-dimensional. Let me show you how to sort of lie this down so we can do 3 dimensions.
It's going to be crazy.
All right, to lie it down, sort of draw your axis this way. So the y-axis is going at an angle. And then you'll have one of your pieces, the top equation, top part of your parabola, and then the other one. Okay, that's the same parabola. I'm just trying to more tip it flat so I can look at it. Okay? Now what it says is that there's supposed to be square slices or square cross sections. So let me show you how to do that. The bottom of the square should touch both of those curves. So parallel to the I'll try and draw it parallel to the y-axis. Draw a segment that touches both of them that's parallel to the y-axis. That should be part of a slice. And the slice is supposed to be a square like the square of butter. So it's a square, oh, that didn't turn out so hot. Square like that. That's one square. It grows up off of the parabola, going up high like that. What if I did connected these 2 points? What would be true about that square relative to the other one? Would it be bigger or smaller? Bigger. If I went from here to here, it would be bigger because it's farther apart. And then I would have a bigger square coming up that way. What if I did mine like from here to here?
Be small.
It'd be a little small square, kind of like that. Okay. So those the bottom corners of every square touches what 2 curves? Yeah. One of the corners touches y equals rad x. The other corner touches y equals negative rad x. So if I want to measure the distance across, I use subtraction. Which one of those is quote unquote bigger? Hi. Which one's bigger? Positive one or the negative one? Okay. So the distance across is going to be the bigger one, the bigger corner, minus the smaller corner. So the bigger corner would be positive rad x minus the smaller corner, which would be negative rad x. So they don't cancel each other out, do they?
No.
Rad x minus negative rad x is going to give me 2 rad x. That measures for me the distance across. All right, so let's finish our geometry so that we can turn this into volume. The area is a square. Every square is just like every rectangle. It will be base times height. And we just showed what's the distance across the base?
2 rad x.
2 rad x. And so then what will the height be if it's a square? 2 rad x. So this would be 2 rad x times 2 rad x. In other words, 2 times 2 is 4. Rad x times rad x is plane x. That is the area. Now, we should be able to turn that into volume pretty easily. Volume then would be the integral. And where am I starting and where am I stopping?
0 to 9.
0 to 9, because that's told, I read that in the problem, 0 to 9. And then I'm going to take 4x dx. So whatever my geometry was, an integral will make it 3-dimensional and turn it into volume. Now, is anything about that constant?
No, 4.
A 4. So you could pull the 4 out to the front if you wanted. So 4 parentheses, or 4 integral 0 to 9 x dx. And you don't need math 9 to do that. I know you could do that integral just by antiderivative, normal.
162.
Okay, all right, let's keep going. Okay, I'm giving you the same base to work with. Find the volume formed by the same parabolic base, but now you're doing rectangular cross sections. Okay, so same shape, so let's draw that. And same y equals positive rad x, and the bottom will be y equals negative rad x. And same distance across. So my distance across is still positive rad x minus negative rad x. In other words, 2 rad x. That's my distance across. But now the shape I want to produce is not a square anymore, but what is it?
A rectangle.
A rectangle. And what in particular about the rectangle?
Twice as tall.
Twice as tall.
Yeah.
So it's not a square anymore, but it's a rectangle that's twice as tall. So like that, maybe? Try and draw that a little straighter. Twice as tall? Okay, so it's a tall rectangle slice. So the geometry for a rectangle is also base times height. And our base across from point to point, we said was 2 rad x. But what will our height be if it's twice as tall? It'll be 4 rad x, which is a total 2 times 2, or 2 times 4 is 8. Rad x times rad x is 8. Once you get that, then turning it into volume should be no big deal. The volume is going to go from the interval 0 and stop at 9 of the quantity 8x dx. Pull the 8 because it's a constant out to the front, and that will turn into a volume. So sometimes a question will say write, but do not evaluate the integral. So you just write the integral. Sometimes they want you to take it all the way and you do it by hand with an antiderivative. Sometimes you get a math 9 if it's a hard antiderivative to do. All right, let's try another one. Okay, I'm giving you the same parabolic base. It's not always going to be the same. We already saw one where it was a sine graph, but we'll stick with our parabolic base again. All right, so parabolic base. All right, y equals negative rad x, y equals positive rad x. And across, we still have the same distance across. Distance across, 2 rad x. All right, we're getting good at that. Okay, this time it's going to be a square cross section, but it's a special kind of square cross section. It's not the same kind of square. It's not this kind of a square. Not like that. That would be a square that grows straight up. This one says something different. This one says the diagonal is parallel to the x-axis. Okay? That means my square is more like a diamond, because a diamond is a square. Right? And then there's an underpiece down here below, like underwater. There's the diagonal.
Oh. That's weird.
Okay, turn your square 45 degrees.
Okay, it looks more like a rectangle, but it's fine.
Yeah, that's okay.
I'm talking about mine.
Yeah, kind of.
Kinda. All right. So we know the distance across is 2 rad x. But our geometry for a square says we don't need the diagonal. What do we need? We need base and height. So how are we going to get the base and the height if all we have is the diagonal? All right, well, let's do a little quick math. No, don't quite need sine and cosine, but okay, so suppose you have, let me just do a regular square. Suppose you have a regular square whose diagonal is 5. How do you figure out what its base and height are?
3, 4.
Okay. Well, what do you know about the base and the height?
They're equal.
Okay, so if I call this B, what do I call that?
B.
B,
Oh, 2B
okay?
is 5.
And so what do I know about B and 5?
B squared plus B squared.
B squared plus
B squared.
B squared equals
25.
5 squared,
2B squared.
right? So 2B squared equals 25.
2B squared or not 2B squared?
So 25 over 2. So B is square root 25 over 2.
Ew.
Ew. Okay, well, that's how you did it if it was 5. What do we know our diagonal is?
Oh, 2 right.
We know our diagonal is 2 rad x.
Oh.
So if our diagonal is 2 rad x, then it's going to be b squared plus b squared equals 2 rad x squared. So b squared plus b squared is 2b squared. What's 2 rad x squared?
4x.
Now what do I do to both sides?
Right.
Divide by 2, so b squared equals
2x.
2x.
B equals.
So b equals,
Plus or minus? Plus plus, because it's plus.
yeah, we have a positive, we'll do the top half of our square, not the bottom, but yes, we would have the bottom, would be the ones on the bottom. So b equals rad 2x. So if the base is rad 2x, what does it mean the height is?
Rad 2x.
Also rad 2x. All right. So that's our geometry. So we're going to have rad 2x times rad 2x, which when multiplied together, it's not 4x, it's plain 2x.
Oh, yeah.
So that's the geometry. And then we turn that into a volume by going 0 to 9, 2x dx, or pull the 2 out. Yeah.
So why would you pull a 2 out if you already know that the integral of 2x is x squared?
Yeah, you don't have to pull the 2 out. You can. Sometimes it's beneficial, sometimes it's not. I know I didn't make one for this, but what if I told you it wasn't a square, it was a circle? Okay, so what if I said it's a circle, that part of it is above and part of it is below, like that, like a penny, right? Like my banana I cut.
Yeah.
Okay, what if it was like that? What if I told you that? Well, what does the distance across tell you about the circle? It's diameter. What's more beneficial to know about the circle? Okay, so the diameter would be 2 rad x. What would the radius be? 1 rad x. And then you would need to turn that into pi r squared.
Yeah.
And you can do it for a circle. Okay? All right, here's one I drew. Let's do a triangle. That's the last one. Okay. All right. So the bottom of this is a circle, but the slices are triangles. So my geometry is going to be triangles. And all triangles are 1/2 base height. So any of the triangles you pick, let's focus on the base and figure out side to side what the distance across the base is. So I'm just going to pick this front triangle that's sitting right there. All right, side to side, how long is the base of that triangle? Well, look at what it's touching. Okay? The triangle is touching the circle on 2 sides. It's touching the circle in quadrant 4, and it's touching the circle in quadrant 3. So I need to come up with what those equations are by getting the equation x squared plus y squared equals 1, getting that by itself. Okay? So if you were working on, well, let's come back to the board again. if you're working on x squared plus y squared equals 1, which is a circle, what do I want to get x by itself or y by itself? Okay, look at the direction the triangles are going. Have we seen them go this direction before? What are they parallel to? They're parallel to the, all the ones we've drawn so far have been parallel to the y-axis. This is different. It's going the other direction. So I want to get x alone instead of getting y alone. How do I get x alone? Okay, so x squared equals 1 minus y squared. What will x be equal to? What? Not just red, 1 minus y squared, plus or minus, because one side is the plus side and one side is the minus side. All right, so let's look at that. This side over here is the positive side. This side is x equals positive 1 minus y squared. The other side over here, that side is x equals negative 1 minus y squared. And my triangle touches both of them. My triangle goes side to side. Which one's bigger if I'm going to do the subtraction? The positive one is bigger. Has to be bigger. I got to start with the positive one. So my distance across from side to side, touching both sides of the circle, my distance across is going to be positive 1 minus y squared minus negative 1 minus y squared. So I've got a double subtraction or a double negative, which means I have 2 times 1 minus y squared. That is the distance across. And the distance across is called the base of the triangle. All right, so now I know what my base is from side to side. So if I'm creating my geometry, 1/2, the base is 2 rad 1 minus y squared. That's the base. How tall are these triangles?
The same.
Why the same?
Because
It says isosceles, right? Isosceles means the base and the height are the same. That's what isosceles, the definition of isosceles. So that is, so isosceles is to triangle as square is to rectangle, right? And isosceles is a triangle of equal sides, just like a square is a rectangle of equal sides. Yeah.
Why did you pick the biggest triangle to find the base?
I could, and it would be the same thing. The biggest triangle is also touching both parts of the circle. So its base would also be 2 times 1 rad 1 minus y squared. They all triangles, no matter what size they are, will be touching the circle. Mm-hmm. Okay, so we clean this up. I have 1/2 times 2 times another 2, and then the 2 square roots times each other. So I end up with 2 quantity 1 minus y squared. Okay, the first 1/2 and the 2 negate each other, and the 2 rads combine. Again, this is the hardest part. Once you have that, you're ready to do your volume. And so your volume will be, what are the bounds of the whole circle side to side? Very good. -1 to +1. Okay, it's a circle. Okay. And then we'll take 2 times quantity 1 minus y squared quantity, and we're using the letter y, dy. So we have done circles, semicircles, squares, rectangles, triangles, and a diamond. Yeah.
Is it possible to do that using extras or no? Because
In this particular case, because it's a circle, you could rotate the circle 45 degrees, and then all of your triangles would be going the other direction, which would have the exact same volume. But like you couldn't do it, you can't rotate like with a parabola. You can't rotate it because it's not symmetric like that.